Good evening. We will start in 2 or 3 minutes. I am waiting for other students to join. So we'll start in next 2 3 minutes. Please wait for a while.
Sure, sir.
Uh, so Good evening, everyone. I'm Rahul Chaudhary. I'm a PMRF PhD scholar from IIT Madras. I am an NPTEL PMRF TA for this course. So I will be taking one session each week from 6 o'clock every Tuesday, and we will be solving few problems based on the previous week, whatever the sessions have been, like the classes, whatever the topics have been covered. We will solve some problems based on that. Just a second. I hope I am audible and my screen is also visible. If you have any doubt or any issues, you can unmute yourself and let me know.
Yeah, we're able to see your screen, but only thing is it's like
Hmm.
better images. The presentation was fine.
Yeah.
Now it is showing the multiple screens of your.
Ha ha ha. Now it will be fine because I
Now it's
opened the
fine.
Google Meet.
Okay, fine.
Okay,
Now it's
thank you.
fine.
So just
Sure.
want to inform, if you have any doubt, you can unmute and let me know. So during the
Sure.
class, you can unmute and let me know. Okay, let's
Sure.
start. And I am also recording the session, and the session recorded session will also be available on the YouTube. So it will take another week or so to show in the this NPTEL portal. So I will go slow, like I will slowly solve the questions. I will give you some time also. Like the session will be most beneficial when you solve along with me. I'm not going to solve very hard problems that it requires more time. So you can also solve along with me and get your doubts cleared. So then it will be beneficial for you. And I also request you, Just before attending the session, try to watch the videos, the lecture videos.
For example, lecture videos regarding the EMI, EMC.
Haha, yeah, yeah, exactly that. For the
Do
current
you have
year.
any video for the EMI, EMC through the NPTEL?
Can you please repeat? I didn't get that.
Do you have any referral videos for that EMI, EMC?
Referral videos are. I don't think you need any referral videos. The lecture videos are sufficient. But I
Okay,
will
fine.
suggest you go through the textbook. That will also be very helpful because the lecture videos are in line with the textbook. So I hope you know what is the
Okay.
textbook for this course.
No, as of now, I am not referring any textbook actually.
Uh,
If you are
I
referring,
I will suggest to use the textbook. So I will show you the textbook just a minute.
yeah, yeah, yeah.
So this is the textbook. This is the front page of the textbook.
Okay.
Just a second. I will. So yeah, those who have joined right now, I was
Right, right
discussing
now, I
about the
was
textbook.
discussing
So this is the textbook Introduction to Electromagnetic Compatibility. So the path you should follow is first watch the lectures and then see the corresponding topics in the textbook. Then it will be more easily understandable.
okay,
As a standalone, lectures are sufficient. That's what I think. But it is good to read the textbook always. So you will get another perspective also. But
okay.
I don't think any another videos are required. Lecture videos are more than sufficient, plus the textbook.
If it is a soft copy, will you be able to share the textbook for
Uh,
us?
uh, that is not possible because I just have the front page and I can't share that because
Okay,
some copyright issues are there. So, but there will be some PDF available online. You just note down the name and you can search for it.
one second.
So this is the official textbook which is our professor is also following. So it has a lot of exercise problems also, which are in line with the lectures. So this live session is just to solve the doubts related to the assignment problems. So I will be solving few problems which are very similar to the assignment problems for the current week. Like let's say for the week 1 I am taking this class. So the problems which I will be solving are going to be similar but not the same as the assignment problems for the week 1. Or any general doubt related to this week 1 lectures if you have, I will try to solve. But yeah, remember there is one group also for the course, Google group. I request you to join that. If you have any doubt, you can ask there also. So I am not the course TA, I am the NPTEL PMRF TA. So there is another TA for the course also, which is a professor's student. So any doubt related to some mistake in assignment problems, you have to write to them because I can't change the assignment problems. That is not in my hand. There can be some mistake in the options. Uh, that you have to write to in the group. But you can notify me. I will try to convey that. So if everything is okay, we can start. I hope you got the name of the textbook. Okay, so good evening everyone. So we will be taking a class live problem solving sessions for the week 1. So all the questions which I will be solving today are related to the topics discussed in this week. This week in the sense week 1. So in this week professor has covered HPEM radiating and conducting environment. HPEM means high power electromagnetic radiating and conducting environments. So conventionally there are two kind of environments in terms of electromagnetic compatibility, EMI, EMC. In terms of EMI, EMC there are two types of conventional environments. So conventional it is divided into two types. Hope my handwriting is not too bad because of this pen I'm using, that's why it is coming out like that. So the first one is narrow band. So here the bandwidth will be less, and the other one is wide band, so which covers a wide band area of the frequency spectrum. And these are narrow band and wide band are divided based on this IEMI classification. IEMI stands for intentional electromagnetic interference environment. Its classification is, first one is, it's based on the its classification is based on bandwidth. So the first one is hypo band. Just a second. So those who have just joined now, just I'm just giving a topic covered this week, a brief to say a brief revision of this, whatever we have covered in whatever professor has covered in this week. So just a brief introduction to that. So first topic that was covered was high power electromagnetic radiating and conducting environments. So which is divided into two types based on the bandwidth, narrow band and wide band. So this IEMI classification, sorry. So this IEMI stands for Intentional Electromagnetic Interference Classification, which is based on bandwidth. They are divided into hypo band, meso band, and third one is sub hypo band. Sorry, sub hyper band. So just a brief revision of what has been covered. So this is divided on hypo band, meso band, super hyper band, and then hyper band. So why this classification is needed is because when they are testing it, because whatever the electronic device, which even it's not emitting anything, but is susceptible to electromagnetic interference. So before making it to the market, there are some tests which has to be done, and those tests are divided into, and this classification of the environment which can be existing. Environment in the sense, in the environment there can be a lot of electromagnetic waves, and if there is a signal which is very high intensity, it can affect the device, any electronic device or electrical device. So to classify those things, this electromagnetic interference and compatibility tests are done. So for that there are environments for the particular device. The one is hypoband, mesoband, subhyperband, and hyperband. So these are divided on based on the bandwidth. So, and that is the bandwidth ratio. They are using bandwidth ratio to classify them. And bandwidth ratio is nothing but it's the ratio of the frequency, highest frequency and lowest frequency in that band. So that's a pretty simple explanation for that. And now next topic that was covered is what is EMI EMC. So EMI EMC is, EMI stands for electromagnetic interference and EMC stands for electromagnetic uh, compatibility, if the device is compatible with that environment or not. So EMI is the impairment of the performance of an electronic system or subsystem by an unwanted electromagnetic signal. And electromagnetic compatibility is the ability of electronic system or subsystem to reliably operate in its intended electromagnetic environment without either responding to unwanted electromagnetic signal or generating unwanted electromagnetic signal. So just I gave you just a textbook definition of what these are. So there is a basic decomposition of EMC problem. So all of these electromagnetic compatibility problems can be divided into or decomposed into this basic block diagram. So there is always a source in the sense this is the emitter which emits that microwave interference, and there is a path which is we called as transfer. So this path is coupling path through which that electromagnetic interference travels to that receptor. This is coupling path. Then the receptor which the electromagnetic interference is affecting or electromagnetic wave is affecting. So receptor is the receiver. So this is like the decomposition of the EMC coupling problem. This transfer path can be wireless as well as a wired media. And this EMI EMC problem are divided into four categories. Four basic EMC sub problems are: first one is radiated emissions, second one is radiated susceptibility. Radiated emission means if the device is radiating any emission or not. Susceptibility, susceptibility is if the device is getting affected by any radiated emission coming from some other source. And conducted emissions are if there is a device which is plugged to the power supply or there is a signal cable connected to it. If that transfer path is because of the wire, if the cable is if the device is causing any interference travel to that path which can affect any other device connected to that. Let's say for one simple example I can say there is one TV connected to the power supply, and in the same power line there is another device connected to that power supply. If that is affecting, let's say some microwave is connected or some any high power motor is connected, if some back current comes, let's say very high impulse pulse goes through that and it can affect the TV, that means that is a conducted emission. And conducted susceptibility is if the television is getting affected from that signal, is its susceptibility. So this is the four basic EMC sub problems. All the problems are divided into these four parts. And then there are EMC standards. So EMC electromagnetic compatibility standards are, this is for digital devices, or it can be for any other device also. So there is a class A device, then there is class B. These are the standards. So EMC standards. So class A are for the devices whose intended use is in a commercial, industrial or a business environment. And class B devices are those which has to be used in a house. Like they are marketed for use in a residential environment, and they are notwithstanding their use in a commercial, industrial or business environment. And the class B limits are more stringent class B than the class B devices, because in a household things are placed in a nearby area, because that area in a factory can be much larger and the devices can be further apart, but in house it's not that. And let's say if something is causing a problem in a household, for a regular user it is very difficult to identify what is the source of that interference. So that's why class B devices, for class B devices which are intended to use in a residential area, the limits are stringent. Limits and all, as we solve problems you will understand. Maybe the limit can be it's the electric field or the magnetic field intensity values. So EMC units and then the professor have discussed the EMC units and signal spectra. So because these variations are more, he must have told you like there is a this is electric field intensity written as 10 volt per meter. In EMI EMC they are usually used denoted in decibels, so they are converted into, or they are put it into dB volt per meter, because the variations are used. That's why they are denoted in the decibel scales. And then the next topic that was discussed in lecture 4 was signal analysis. So signal analysis, you must have seen a periodic pulse signal, and then the Fourier transform was taken. Fourier series, because that was the periodic signal. So that was done in order to, because the spectrum, we need the spectrum in the frequency domain. Suppose this is a signal, and if you want to denote it in the frequency domain, because all these standards and limits are in the frequency domain, that's why they are divided into this bandwidth, right? EMI classification based on the bandwidth: hyperband, mesoband, sub-hyperband, hyperband. All of these are in frequency domain. So that's why this, for a periodic signal, a Fourier series was done for the signal analysis. And this signal is the interference signal, that EMI signal, high intensity electromagnetic signal, which is being emitted by some device, which is unintentional in our case. So for that, to understand it, a mathematical analysis has to be done. That is being done in the frequency domain. That's why the signal analysis topic was covered. And then signal sided spectrum. And then the last topic was discussed, which is still continuing in the week 2 also, is the signal sided spectrum, single sided spectrum. So that's just a brief brief revision of the topics that have been covered. Now we will solve few problems based on these topics. So first few 10 questions are very basic and you already have gone through it. These questions are from the week 0 problems. So here we will understand, and I think everybody knows that, but still I will go through them. Basic conversion in the units. So we have to convert the following voltages to decibel microvolt. So here three voltages are given. First A is 20 millivolt. So I hope you are also solving along with me. If you have any doubt, just let me know. And we have to write it into decibel microvolt. So now we have to convert into dB scale. So log 10, 20 log base 10. This is 120 into 10 to the power minus 3, and we have to write it into microvolt. So that's why I have to include this 10 to the power minus 6 in the denominator. So this is in dB microvolt, and when we solve this we will get 20 sorry I'll directly solve it here because there is not much of explanation to do about this. Just you have to solve the log 10 of this 20 into 10 to 120 into 10 to the power minus 3 divided by 10 to the power minus 6, and when this goes up it becomes log 10 into 120 into 10 to the power 3 multiplied with 20, and when we solve this we will get 101.58 dB microvolt. I hope this is clear. If you have any doubt in this, please let me know. If it is clear, then same we will move on to part B of the problem, where 0.04 microvolt is given, and same thing we have to write it in dB microvolt. So for this one, this is already in microvolt, so we just have to take the 20 log base 10 0.04, which comes out to be minus 27.96 dB microvolt, and part C is given as it's a 48 volt. We have to write this in dB microvolt. So 20 log base 10, 48 divided by 10 to the power minus 6. So when we solve this, we will get 153.62 dB microvolt. This was a very pretty simple question. If you have any doubt in this, please let me know. I can explain it again also. If this is clear, we will move on to question number 2. This is also pretty similar, but here instead of just voltage values, we have current values also and power values also, because this 20 millivolt, 50 microvolt, then 10, 100 milliamperes, then the values are in some power values are also given. We have to convert in the units which are in the brackets. So determine the following quantities in the indicated units. So I request you guys also solve along with me. You can have a pen and paper and solve it, and use your calculator also. That is good. But during the exam, you won't be allowed to use your own calculator. There will be on-screen calculator that you have to use. So just remember that. So the first quantity which is given is a voltage 20 millivolt, and we have to write down this in decibel microvolt. So this question seems simple, but as we progresses in the subsequent weeks, right? These values will be useful because all the values will be in decibels, and it's good if you go through some basics of that. That's why I recommend you solve few problems from the textbook, chapter 1. That will be really good if you solve them. Just few problems, it will be easy for you. So now we have to write 20 millivolt into dB microvolt. So same, it's pretty similar to the previous questions. 20 log base 10, 20 it's in millivolt, divided by, we have to write in microvolt, so we have to divide it with 10 to the power minus 6. So, and when we solve this, we will get 86.02 decibel microvolt. So the first few questions are pretty simple, and as we progresses with question number 5, 6, it becomes little bit more tougher. Still, they are for week 1 questions are very simple. So 50, next quantity is 50 microvolt, and we have to write this in dB millivolt. Okay, now the difference between the previous question and this one is, instead of writing in dB microvolt, we have to write in dB millivolt. So same thing, 20 log 10, 50 into 10 to the power minus 6, because this is in 50 microvolt, divided by milli 10 to the power minus 3. And when we solve this, we will get minus 26.02 dB millivolt. I hope this is clear. If you have any doubt in this, please let me know. And the next value is 100 milliampere. So our current value is given, and we have to write this in dB microampere. So same thing, 20 log base 10, 100 into 10 to the power minus 3 divided by, because we have to write in microvolt, so we have to divide it with respect to this, and it comes out to be 100 decibel microampere. And the next quantity is power. It's a 30 watt is given, 30 watts, and we have to write in dB watt. So now we have to use this 10 log base 10, 30, which gives 14.77 dB watt. I hope this is clear. I know everybody knows this, but just for just just to say it, I am just saying it here. The definition of the direct decibel unit, dB unit, is based on a ratio of power levels. So dB is always in a 10 log base 10 with respect to the, it's a ratio of power levels with P2 by P1. So that's why you will see for every power quantity, what we always use the formula to convert a power unit into decibel. We always use 10 log 10, not 20 log 10 as in case of current and voltage, because P is, we can write power as in terms of current as I square R using Ohm's law, and also we can convert it into voltage. V is equals to P is equals to V square by R. So now if you want to take the P2 by P1, this ratio in terms of current or voltages, it will be V2 square V2 square divided by R divided by P1 is V1 square by R. So it will be V2 by V1 whole square. So now if you want to write this quantity in terms of voltage and dB scale, we have to write 10 log base 10. Instead of P2 by P1, we are replacing it with V2 by V1 whole square. So the square on the based on the log properties, I'm just simply writing, I can write it as 20 log base 10 V2 by V1. So that's why we are doing this. I know everybody knows that, I just repeated it. And then the next the next quantity is 300 microwatt, and we have to write in dBm. So whenever somebody is writing some quantity is given in dBm, it means this is a power in milliwatts in dB scale. So dBm is a quantity of, is a unit for power. Here you see watt is not given explicitly, it's not written. Like in case of voltage and current, it was milliampere, millivolt, something, but for power, watt is not needed. dBm is unit of a power. So to convert this into 300 microwatt, we have to write it in dBm. So 10 log base 10, 300, it's in micro, so 10 300 into 10 to the power minus 6, and we have to write it in milli, so we have to divide it in with 10 to the power minus 3. So this is our P2, this is P1. So when we solve this, we will get minus 5.23 dBm. So I hope this is clear. If you have any doubt in question number 2, please let me know. Okay, if that is clear, we will move on to question number 3. Now in question 1 and 2, we have written a quantity which is given in the standard unit as 20 millivolt. Then we have converted into dB scale, but here we have to do the opposite part. we have to write the absolute value of the following quantities. So first one we are given as 60 decibel microvolt per meter. So volt per meter, I think everybody knows, is a unit of electric field. So some electric field intensity value is given in dB scale, and we have to convert it into the absolute value. Absolute values in the sense, like for in terms of electric field, in terms of volt per meter, we have to write. So the absolute value, we can write this as 60 dB microvolt per meter. We know we have to write this as, it came out from this only, right? 20 log base 10, and this is the absolute value. We don't know, that's why I'm writing it as x. Let's suppose this is x. So then x will be equal to 60 divided by 20, and since if we have to remove the log which has a base of 10, so we can write it this as a 10 to the power 60 by 20, then it will be in microvolt per meter. And when we solve this, so 10 to the power 3 microvolt per meter. So we can still write it in this form. 10 micro, I can write 10 to the power minus 6 volt per meter, and when we solve this, we will get 10 to the power minus 3 volt per meter, or I can also write this as 1 millivolt per meter. 10 to the power minus 3 I can write as small m, so 1 millivolt per meter. So this is the solution for this part. If you have any doubt in this, please let me know. So we will move on to the next part, 120. Next quantity is given as, this is also electric field, 120 dB microvolt per meter. So if you think I am going too fast, just let me know. I am trying to be slow so that you will get time to solve the questions along with me. But still, if you think I am going fast, you can let me know, I can slow down also. So next quantity is 120 dB microvolt per meter. So same thing, I can simply write it as, just to remove the log, and the 20 log comes into the denominator for 120 divided by 20. So I'm just simply writing this directly here, so I don't need to do this step, I'm directly going this step. So the quantity is in microvolt per meter, so 10 to the power 120 divided by 20 microvolt per meter. And when we can simplify this as 10 to the power 6 into micro is 10 to the power minus 6 volt per meter, and when we solve this, we will get 1 volt per meter. So, and the next quantity which is given as 30 dB millivolt. We have to write it in volts, in absolute value. So we can simply write this 10 to the power 30 divided by 20 millivolt, and when we solve this, 10 to the power 1.5 is 31.62 millivolt, and the next quantity, last quantity, is 66 dBm. So if it is only dBm, you have to keep it mind in, understand that, remember that this is a power quantity. So now 10 to the power 66, instead of 20 it should be 10 here, instead of 20 it should be 10, so 10 to the power 66 divided by 10 milliwatt. So when we solve this, it comes out to be 3981.07 watt. I hope this is clear. If you have any doubt in this, please let me know. Okay, if this is clear, then we will move on to question number 4. So question 4 is, which of the following scenarios comes under the study of electromagnetic interference and compatibility? Radiated emission, radiated susceptibility, conducted emission, and conducted susceptibility. So I think everybody knows that the answer is all of the above, because all four are the classification of a EMI EMC problem. Any EMI EMC problem is divided into either these four categories. So all four of them are studied under the electromagnetic interference or electromagnetic compatibility. So in the subsequent lectures we will see we will be covering all four of them. So the correct answer for this is option E, all of the above. Now we will solve question number 5. Question number 5 is, an antenna is radiating in free space. A spectrum analyzer records. So a spectrum analyzer is an electronic device which is a measuring instrument basically, which measures the spectrum, and it gives the values like how much intensity values for voltage, current, for a frequency signal. So it records So an antenna is there which is radiating in a free space. Let's say this is antenna and it's radiating in a free space, and there is a spectrum analyzer which records the intensity. Let's say the spectrum analyzer is connected to one probe which measures the intensity of this radiation emitted by this antenna, and it records as 60 dB microvolt per meter at a distance. So this point is P, which is 50 meters away. So the spectrum analyzer records 60 dB microvolt per meter at some observation point P. So this is our observation point P, which is recorded by spectrum analyzer this point P is at a distance of 50 meters from the antenna. So this distance is 50 meters. We have to determine the absolute value of the electric field intensity at this point P. So these 50 meters and all are not even needed here in the problem. The ultimate our goal is in this question is we have to write down this 60 dB microvolt per meter in the absolute value, which we have already done in the question number 3. So this 6 whatever this spectrum analyzer is recording, it gives the values in dB microvolt, or it gives in dB scale basically, because the variations are huge in the data, because some signal can have intensity of 6, let's say 600 volt per meter, or one can have 60 microvolt per meter, just one example. So that's why they are measured in dB scale. So dB microvolt per meter we have to write in the absolute value for the electric field intensity at point P. So we have to do nothing but same thing what we have repeated in the previous problems. So 10 to the power 60 divided by 20 microvolt per meter, because this is given in dB microvolt per meter. So 10 to the power 3 into 10 to the power minus 6 volt per meter, and when we solve this we will get 1 millivolt per meter. So if we match it with the option, then the correct option is option A. So option A is correct. I hope this is clear. It's just similar what we have done in the question number 3. So if you have any doubt in this, please let me know. Okay, if this is clear, then we will move on to the next problem, question number 6. So what is the primary purpose of electromagnetic compatibility in electronic systems? 4 options are given in increase power consumption, maximize signal speed, ensure proper functioning in the presence of electromagnetic interference. Option D is enhance resistance to physical damage. So if you just go through the options itself, you are able to understand. The correct option is option C, because that's what the use is. That's why we are studying electromagnetic compatibility. to ensure proper functioning in the presence of electromagnetic interference. Compatibility means if there is an environment in the environment, lot of electromagnetic interference is there, and suppose one device is there, we will say this is compatible, electromagnetic compatible only if in the presence of this in a interference environment still it is able to function well, then that device is electromagnetic compatible. So this is the primary purpose of electromagnetic compatibility in electronic system, to ensure proper functioning in the presence of electromagnetic interference. So one simple example that I can give of one EMC problem is, suppose I guess everybody must have faced it, like we are working on our laptop and suddenly one blue screen comes and then it says something went wrong in the windows. So that happens because of some interference which has affected your CPU. So instead of one, some quantity becomes something else because of this interference. It happens rarely, but it can happen. So it doesn't make sense, it doesn't make that device incompatible, but sometimes some interferences are very strong and they can cause these problems. Even a device is compatible, but it may not have been tested for that particular frequency because it may be very high. That's why sometimes, rarely it happens, but it happens that sometimes our windows stop working and a blue screen comes. That is a basic example of electromagnetic interference from the environment. And a lot of different examples. I just give you one simple example here. Now we will move on to question number 7. Which of the following is a common source of electromagnetic interference in electronic systems? 4 options are given. Can anybody tell what is the correct option here? That is also very basic. That common source of electromagnetic interference in an electronic system.
Power line.
Yeah, exactly. Power lines are the main source of electromagnetic interference. It's a type of radiated emission. I don't know why the question number 8 is not visible. We will move on to question number 9. Question number 9 is, what is crosstalk? So crosstalk is, there are 4 options: unintended interference between adjacent signal paths, propagation delay in transmission line, optimization of power consumption, enhancement of signal speed. Even if you go through the options, the correct option itself sounds A
Yeah.
only. It's an crosstalk is, there is one signal going through one power line or some telephone cable. It doesn't happen usually, but there is a chance of this can happen, because earlier when landline used to be there, sometime the crosstalk happens, like somebody has called somebody and someone else is receiving it because of the crosstalk. This is like very crude example of crosstalk. A lot of different examples can be there. I just give you one very simple one. So now we'll move on to question number 10. What does the term grounding refers to in context of EMC? So ensuring devices are securely placed on the ground. Definitely not. That's what grounding means. Part option B is providing a common reference potential for electrical circuits. So this is the correct option, option B. Option C, maximum power consumption. No. Why do we want to have maximum power consumption? Option D is enhancing resistance to physical. No, that's not the part of EMC itself. In electromagnetic compatibility, we are not worrying about the resistance to the physical damage. So correct option is option B, providing a common reference potential for electrical circuits. That's why like proper grounding is needed. Even ESD can cause a problem to a device if it is not properly grounded. ESD is the electrostatic discharge which can happen because if you touch a device from us also. So that's why proper grounding is needed. Now question number 11. So question number 11 is, the electromagnetic spectrum ranges from. So if I just give a brief overview of EM spectrum, electromagnetic spectrum. So electromagnetic spectrum consists of radio waves, microwaves, infrared, visible, ultraviolet, X-rays and gamma rays. So, radio, microwaves, infrared, just a second. So I'm just giving a noting down what are the different waves or are there in a electromagnetic spectrum. It consists of radio waves, microwaves, infrared, visible, ultraviolet, X-rays and gamma rays, and their wavelengths are, I'm writing down the wavelengths in meters. Radio waves, the wavelength is for a radio wave, it is 10 to the power 3 meter. Microwaves are generally their wavelength is in 10 to the power minus 2 meters. So that's what we are using nowadays for communication. Almost all of the telecommunication happens with microwaves. And then infrared is 10 to the power minus 5. Infrared we are still using it to control the televisions in the remote control. That can be used for a very near field communication. So that's what this infrared is. Visible is the visible light that we see. Its wavelength is 0.5 into 10 to the power minus 6 meters. Ultraviolet wavelength is in 10 to the power minus 8. X-ray is 10 to the power minus 10 meters. And the gamma rays, which are the cosmic rays, which comes from the outer space, has a wavelength of 10 to the power minus 12 meter. So here if you are seeing this, the wavelength is decreasing as we are going towards the higher energy waves. It's reducing, sorry. Wavelength is reducing as we go through this. And if we talk about frequency, frequency increases as we go along radio micro, because the gamma rays has the highest frequency. So now the question what is asking is the electromagnetic spectrum ranges from, so it is asking in terms of wavelength. So we can see it ranges from 10 to the power 3 meter means a kilometer to 10 to the power minus 12, which is picometer. 1 picometer. So the correct option here is option C. I don't know why this question number 12 is not visible. So I will just verbally tell you what question number 12 was. So it was asking about, so it has given some options of some waves, like it has given gamma rays, X-rays, ultraviolet and radio waves, and it was asking which of the following can pass through our Earth's atmosphere. So Earth's atmosphere allows visible light, which is a part of the electromagnetic spectrum, and certain radio waves to pass through while blocking harmful gamma rays and X-rays. Certain radio waves to pass through while blocking harmful gamma rays. So gamma rays are the cosmic waves which is being blocked by our atmosphere. Also our atmosphere blocks X-rays, and that's why if you see lot of amplitude modulation has to be done, amplification has to be done if we are sending some signal to some probe for free space communication or something, for to if some space probe is out there, let's say Voyager, if we are sending some signal or receiving some signal, it has to be amplified, because our Earth's atmosphere, when it enters our Earth's atmosphere, lot of degradation will happen in the signal strength. That's why a high amplitude this amplification is needed. So 12 and 13 questions are not visible. So 13th question was basically talking about the FCC regulations, uh, like what kind of frequencies has to be, which harmonics has to be studied. If suppose a device is there, let's say a microprocessor is there which operates above 1 gigahertz. So FCC is this Federal Communications Commission. FCC stands for Federal Communications Commission. So FCC regulations require devices with clock frequencies above 1 gigahertz. If a device has a clock frequency above 1 gigahertz, has to be tested. This device has to be tested up to the fifth harmonic. Fifth harmonic to ensure compliance with the emission limits, because there will be harmonics of a signal, even though they will be less in the amplitude wise, but still their harmonics exist. Suppose if a device is there which operates about 10 gigahertz, so then there will be some harmonics of 20, 30, 40, 50. These harmonics will be there, but their spectrum intensity will be very less. But that's why they have to be tested up to the fifth harmonic to ensure compliance with the emission limit. However, due to practical constraints such as the cost and complexity, testing at very high frequency, the upper limit for testing is set as to be 40 gigahertz. So if any device operating the harmonic of a device, let's say if it operates at the clock of 10 gigahertz, so it will be tested up to 40 gigahertz. This is the maximum limit because of the complexities involved in testing at a higher frequency. So that's why we don't have even if we have a spectrum analyzer which can analyze a spectrum above 50 gigahertz or 40 gigahertz, it will be very, very expensive and very hard to make. So that's why the testing is limited up to 40 gigahertz. So that's what the question was asking, what is the limit up to which we have to test. So that the answer was 40 gigahertz, or whichever is the lower, up to fifth harmonic or up to 40 gigahertz. Question 14, determine the ratio of two powers P1 and P2 and two currents I1 and I2. So ratio in the sense we have to write it in dB scale. All the options are in decibels. So two power values are given. First part is power in decibel. So for power we know 10 log base 10 P2 by P1. Sorry for the handwriting, this pen is giving some problems today. So next class I will try to resolve it. So 10 log 10 P2 is given as 15 volt and P1 is 5 milliwatt. So 5 into 10 to the power minus 3. And when we solve this, 10 log base 10, 3 into 10 to the power 3, it gives 34.77 decibels. And then second part we have to find the current ratio, means current in decibels. Current in dB is 20 log I2 by I1, which is 20 log I2 is given as 0.2 amperes and I1 is 5 milliamperes. So when we solve this, 20 log 200 by 5, so it gives 32.04 decibel. So we got 34.77 dB and 32.04 dB. Now we will match the options 34.77 and 32. So the correct option is B. I hope this is clear. Now we will move on to question number 15. So question number 15 is asking about which of the following is a characteristic of hyperband system in high power microwave applications. So first I will explain what these hyperband systems are. Hyperband systems are defined by having a bandwidth ratio, having bandwidth percentage between 163.64%. So this has been explained in the lecture 2, I think. So the hyperband systems are defined by having the bandwidth ratio percentage between 163.64% and 200%. Sorry, the bandwidth percentage should be in between 163.64% and 200%, and the bandwidth ratio should be greater than 10. Ratio greater than 10. So that's what a hyperband system is. So hyperband systems, the bandwidth percentage should be no. Option B is bandwidth percentage between 1 to 100, no. Bandwidth percent greater than 163.4%. So here the only correct option is option C. Here for a hyperband system, the bandwidth percentage are greater than 163.64%. So if you ask me what is a hyperband system, these are the specialized type of antennas or signal source used for generating and transmitting extremely wideband high power electromagnetic pulses. They are typically used for testing the immunity of electronic equipment. So that's why they are making a electromagnetic interference environment in the testing facility. So hyperband systems are These are specialized type of, it can be an antenna, type of antenna or signal source used for generating and transmitting extremely wideband extremely wideband high power electromagnetic pulses electromagnetic pulses typically for testing the immunity of electronic equipments. Electronic equipments. So now we'll move on to question number 16. So here 16 is also not visible. So 16, question 16 was just basically talking about uh, what are this electromagnetic interference refers to. So EMI refers to unwanted deterministic signals interfering with the system, and it was asking what is the difference between the noise and a EMI, how electromagnetic interference signal is different from noise, because you must have heard there is a EM noise also sometimes, and how it can be different, how it is different from electromagnetic interference signal. So EMI refers to the unwanted signal but deterministic. Electromagnetic interference is always unwanted but deterministic. So means we can do a mathematical modeling of that, and we can make filters or some kind of shielding for the device. Unwanted but deterministic signals interfering with the system, whereas noise is random, it's always random. So these are the stochastic signals, these are always random and undetermined. We can't predict what will be the noise. So that's why we in this course for EMI we are doing the mathematical modeling of signal. That's why the signal analysis topics is there, signal integrity. All of these topics are there for EMI because it makes sense. We can have a predictability model for that. They are still unwanted, but they can be deterministic signals. So that's what the difference between a EMI signal, this electromagnetic interference signal, and a noise. So now we'll move on to question number 17. An RG58U coaxial cable has a loss is given as 4.5 decibel for every 100 feet. If the cable is matched to the output, then the attenuation constant at 200 MHz and 400 MHz respectively are. So if you have watched the lectures, you have remembered there is a formula that we derived for the cable loss. So same formula we have to use here. So the cable loss is given by the cable loss is given by 10 log 10 e to the power 2 alpha L. This is the formula for the cable loss. So we can write this as 20 alpha is the attenuation constant. So that's what we have to find in the problem. Attenuation constant 20 alpha L, where L is the length of the cable, log with base 10 E. So we already know what the cable loss is. It's given as 4.5 decibel per 100 feet. So in per 100 feet we will put L as 100. We are taking the cable length as 100 here. So the alpha will be 4.5 divided by 20 into L into log 10 E. So if we take log 10 of base log 10 of E, it comes out to be something like 0.4, and if you multiply it with 20, the value will be 8.686 into length, and in numerator 4.5 was there. So when you solve this, 4.5 divided by 8.686 into 100, we will get alpha is attenuation constant 5.18, sorry, 5.18 5.18 into 10 to the power minus 3 Napier per feet. So it's in Napiers per feet. So this is what the answer we got, and if we will match it with the option, so the correct option here is option A. So if you look here at, they are asking the attenuation constant at two different frequencies, but if you see the formula, it does not even depend on the frequency. The same loss will be, attenuation constant will be same for 200 megahertz signal and 400 megahertz signal. If for in the coaxial cable, let's say if two signals are going, one with 200 megahertz, one with 400 megahertz, both will have the same attenuation constant. So the correct answer is option A, 5.18 into 10 to the power minus 3 Napiers per feet. Same for 400 megahertz also. So if you have any doubt in this, please let me know. So if this is clear, we will move on to question number 18. What is the primary reason why class B devices have stricter EMC requirements than class A devices? So we have discussed in the starting of this session also. In residential settings, emitters and receptors are closer compared to a commercial building where the space is more and these electronic devices are far apart, or any devices are far apart. So that's what class A devices are. But in class B devices, they are in residential settings and emitters and receptors are closely placed together. Emitters and receptors are closer, which increases the likelihood of interference, increasing the likelihood of interference. Additionally, the residential user often lack the expertise or resources to mitigate electromagnetic interference, necessitating stricter standards for Class B devices. Additionally, the residential users often lack the expertise or resources. So you can't expect to a residential user to have a spectrum analyzer and to analyze a spectrum in his house, like what is causing the electromagnetic interference. That's why, to mitigate the EMI EMC issues, Class B have a stringent or a stricter standard for Class B devices. Expertise or resources to mitigate EMI EMC, mitigate the electromagnetic interference, necessitating stricter standards for Class B devices. So now if we go through the options, Class B devices are typically used in residential environment with closer emitter receptor proximity. Class B devices are used in industrial environment with high electromagnetic interference. Option B itself is not correct. Class B devices are never been used in, they are not used in industrial environments. Class B devices emit higher electromagnetic radiation than Class B devices. No, this is also not correct. Class B devices are larger and more complex. That is not necessary, right? So if we see, the correct option here is option A. Class B devices are typically used in residential environments with closer emitter receptor proximity. That's why Class B devices have stricter EMC requirement than Class B devices. I hope this question is clear. Now we will move on to question number 19. So in question number 19, for a periodic square wave pulse train, the complex exponential expansion coefficient is given by. So the same problem has been solved in lecture 4 also. If you see the lecture 4, professor has solved the same problem. They have used this square wave pulse train and then so we will solve it again here, no problem. So this is given as, so for this, since it is a periodic signal, we will use Fourier series. We will use Fourier series to get the frequency domain. Fourier series. So first C naught, anyhow they are not asking for C naught, but still I will write down the formula of C naught here. 1 by T T1 to T1 plus T xt dt, and when we solve this, 1 by T 0 to tau, because after tau the signal is 0, right, and the period of the signal is T here, this, so up to 0 to tau the signal is A, this amplitude is given as, and after t to tau to t is 0. That's why I'm directly writing is from 0 to tau. Amplitude a xt is a dt, and when we solve this, a tau by t. But in the problem they are asking for the complex exponential expansion. Cn, the nth coefficient of the Fourier series expansion. The formula is t1 to t1 plus t xt e to the power minus jn omega naught dt. Then again we know from 0 to tau the signal is x of t is a, and after that it becomes 0, so I will write x of integral from 0 to tau x of t is a e to the power minus j n omega naught t dt. So when we solve this integral we will get a divided by t into minus j n omega naught into e to the power minus j n omega naught tau minus 1. So I can write this as Cn is equals to, so we can write this e to the power minus jn omega naught tau minus 1 by taking this e to the power minus jn omega naught tau by 2 as common. So what I meant by this is I can write this as minus a divided by jn omega naught t e to the power minus j n omega naught tau by 2 into e to the power minus j n omega naught tau by 2 minus, I'm taking this as common, so I can write this here as e to the power, so basically when we multiply this it becomes e to the power 0, which is basically 1, so that's why I'm writing this here as e to the power j n omega naught tau by 2. So I did this because now this term we can write in terms of sign, so it becomes a to the power j n omega naught t so now we can write this a to the power j n omega naught t into e to the power, which we took common, n omega naught tau by 2, and this term I'm writing here as sine, so that some minus sign came here and it neglects that, so sine n omega naught tau by 2 into minus 2j, that's why I'm removing this minus sign here, 2j. So when we solve this again, this j gets cancelled here, and we can rewrite this in terms of a by a into tau by t e to the power minus j n omega naught tau by 2 into sine n omega naught tau by 2 divided by n omega naught tau by 2. So to bring this tau here in the denominator, I have multiplied and divided it, so here also that's why numerator tau came. So it helps us. Now we have to write the magnitude part. Is magnitude of Cn is a tau by t, and I am again putting modulus because sine can be both positive and negative. So sine n omega naught tau by 2 divided by n omega naught tau by 2. And in the problem we have been asked about the angle also. Okay, angle of this Cn is, here this is the angle part, right? So it will be plus minus n omega naught tau by 2. So if we match it with the given option, the correct option is okay. There is a problem in the options here, or they have written it in the such way that, because we know that omega is 2 pi by t, so here they must have replaced this. So if I write in terms of t is 2 pi tau t into 2, if we do this I can write this plus minus n pi tau by t. So the options are in this form. So if we match it with the given options, the correct option would be, so simply we just have to replace all of them. It's not in terms of omega, that's why everything is here in t. So if you replace it and get the correct answer. I hope the question is clear. If you have any doubt in this, please let me know. So those who have joined late also, I will be uploading this lecture, this session on YouTube also. The link will be available in the NPTEL course page. You can see from there. So here in this we are not doing, we are not taking a lecture or a class here, or just a problem solving session. So I will be solving few problems based on the problems or the topics that have been discussed in the previous week. That means the currently week 2 is going on, but I am going to solve, like I am solving problems based on the topics covered in week 1. So now we will move on to question number 20, and the idea of this session is to help you understand the topics which have been discussed in the previous week, and also to help you solve the assignment problems. So if you see, all the problems which I am solving today are very similar to the assignment problems. They are not exactly same, but pretty similar. So now we will move on to question number 20. So question 20, for the waveform shown below, the Fourier series expansion coefficient C naught is given by, so okay, they are asking for the C naught. So which is pretty simple only. So but first we have to write down this signal x of t. So x of t, if we see, is, we can divide it into 3 sections. Section 1, 2 and the third one, based on the time t. Since it is a periodic signal, we just have to write this first period. So I can write this as t by 2m. So everything is in milliseconds, that's why I'm writing is at 2m. Instead of writing 2 into 10 to the power minus 3, I'm writing as 2m. T by 2m. Because if you see, between time t equals to 0 to time t equals to 2 milliseconds, in this section, this is like this is following this pattern, and between, when time is in between 2 millisecond to 5 millisecond, it is always 1. So in the second part, it is between 2 to 5 milliseconds. The amplitude here of this signal is 1, that's why I'm writing it as 1. And between 5 to 10 milliseconds, the amplitude becomes 0. So that's, we can simplify the signal and write in a mathematical form. So that will help us while we are taking the Fourier series, right? In 10 milliseconds. Now in the problem they are asking about C naught, to calculate the C naught. C naught is given by 1 by t1 within the integral limits of t1 plus t x of t dt. So 1 by t, and from the limit 0 to 2 our x of t is t by 2m dt, plus between the limits 2 to 5 milliseconds it is 1, x of t is 1, so 1 dot dt, plus, and between the limits 5 milliseconds to 10 milliseconds it is 0, that's why 0 dot dt. And when you solve this you will get, so 1 by t, so this becomes 1 by 2m into t square by 2, and the limits are between 0 to 2m. So just don't forget the m. Instead of writing, either we should have skipped the m throughout the problem in the when we are defining the xt now, but since I have done that, so let's keep the limits into in milliseconds. So instead of writing 10 to the power minus 3, I'm just simply writing m plus, so this is 1, right? So t 5 minus 2m, 5m minus 2m, and the next part is 0. So when we solve this we will get 1 by t. So when I put on the limits here, 2m into 4m square by 2 plus this becomes 3m here, and when we solve this part, 1 by t into 1m plus 3m, which is 4m divided by t. And if we see the signal, this periodic signal here, we can see the periodicity of the signal is t is 10 milliseconds. That means it is repeating after every 10 milliseconds. So t also we know it is 10 milliseconds, so we will substitute t also here, 10m. So C naught comes out to be 0.4. If you match with the given options, so here options are not correct. There is no 0.4 is given, so that's the options are not correct here. So the correct answer is 0.4. So this is one of the problem from the previous year assignments. There this issue was there. So if you saw any of these issues in this year's assignment problems, right, either you let me know and I will inform the NPTEL team, or you just send one email to the group. That will be the best way, because then immediately the course TAs can be informed. So I request everyone to join the group. There is a course discussion group, a Google group is there. So that's all for today. If you have any doubt in the problems that we have solved today, just let me know. I will be here till 8 o'clock. I will be available in this link till 8 o'clock. Or if you have any doubt also, I will give you my email address and you can write me one email and I will reply to that. My email ID is ed22d009 @smail.iitm.ac.in. So you can write me on this email and I will surely reply to your problems. And every week we will be meeting from 6 to 8 p.m. every Tuesday, and I will be solving some problems which are similar to the that week's assignment problems. So please do join, and if you have any doubt, please get it clear. Thanks for joining. If you have any doubt, please let me know. if you don't have any doubts, that's all for today's session.
Thank you.
Thank you.
Can you repeat that book name?
Yeah, sure. I will show you the book name, the front cover. This is the textbook for the course, Introduction to Electromagnetic Compatibility. So that will be good if you go through the problems, or at least just go through the text. First, I will recommend to go through the lectures, and then you can go through the textbook of the subsequent topics in the book. But most important part is you just go through the lectures first, uh, NPTEL
Yes, yes.
lectures from our professor. That will be more important.
Mm.
But some problems are pretty good in this. Even the example problems are good. If you go through them, it will be beneficial for you. So that's all. If you have any doubt, let me know. Or you can solve the assignment textbook problems, and if you have if you found any issues in that, if you have any doubt in those problems, textbook problems, we can meet every Tuesday, and then we can discuss those problems also.
Okay, okay. Thank you very much.
Yeah, thank you. Hi Suraj, the session for today is over. So, but don't worry, I have recorded the session and I will be sharing the recorded link on the YouTube. It will be uploaded in the YouTube and the link will be shared on the NPTEL course page.
Okay, so can I access through the I mean my account, right?
Yeah. You have registered for the course, right? Means like just
Right.
registered, not even for the exam. You just register and you can use it, access it.
Yeah, I have registered. So what
Yeah.
was the agenda? I mean, what was the agenda for this meeting?
Okay.
I mean,
So
not
this
agenda, the topics.
This was a problem solving session. So I am a PMRF scholar. I'm a PhD scholar. And as
Okay.
part of the scholarship I'm getting, there is one criteria that I have to fulfill. Like I have to complete a teaching assignment, teaching duty. So I'm a course TA for this NPTEL PMRF TA for the course. And every week I will be taking a live problem solving session,
Hmm.
which starts on every Tuesday from 6 p.m. to 8 p.m.
Okay.
So here I will
Yeah,
be
I'll try to
solving.
join next time. Yeah.
Yeah,
So,
yeah. So the idea here is just to solve some problems and give a pretty basic revision of what are the topics have been covered, and then I will be solving few 10 or 20 problems which are related but not the same as the assignment problems. But I
okay.
can't
Okay.
solve the
Good.
exact problems, but they will be pretty similar.
Okay. Sure. Sure. Yeah.
And I will be solving your doubts related to the course, the content of the lectures.
Okay.
If you
Sure.
have
Sure.
any
Thank
doubt, and okay, just go. And this is the textbook that professor is following in the course. So I
Which
request you
one is
to.
that?
This is the textbook for the course.
Not able to see it. Are you share your screen or?
Oh, okay. Oh, yeah. I haven't shared my screen. Just a sec.
Okay, it's a signal integrity book or like how it is?
It's a combination of both. It's a EMI EMC book. It's not,
Okay. Okay.
but it covers all the topics that have been covered in the lectures.
Okay.
So I hope you can see the screen now, right?
Yeah, I can. I can.
So this is the textbook. There will be one e-copy available online also. So, but
Okay. Okay.
that will be good if you watch the lectures first and then go through the textbook. And
Yeah.
I
Sure.
will
Sure.
also be solving some of the problems from the and exercise problems from the
Okay.
textbook.
Mm-hmm.
So, if you want to solve yourself also, you just go through the textbook, solve the problems, and when we are meeting in the live session, you can ask any doubt if you have.
Sure. Sure. Yeah.
So that will be a pretty good use of the session. Otherwise, if I will be just solving the problems, I don't think it will be much of a use for anybody. But if you
Okay.
have
Okay.
watched the lectures and if you have any doubt, then it will be good.
Yeah. Yeah. Actually, I have one
Yeah,
more story on the course. Okay.
yeah,
So how so actually I'm working as a hardware design engineer. Okay.
yeah.
So on a product level, right? How effective this will be? Or I mean, will I be able to map these things to a product design point of?
Yeah,
Uh,
yeah. So this is the first introductory course, introduction course to the EMI EMC and signal
hmm.
integrity. There are much more advanced level courses for the working professionals, but I think this is the base which creates
This is the base
the
I can
foundation.
start
Yes.
with.
So yeah. So if you
Okay.
have electronics background, this course will be much easier for you to follow.
Okay. Okay. Yeah.
Hmm.
So after this course, maybe I can do the next one. That's
Yeah,
out.
there will definitely for working professional also and will provide some lectures and some courses, certification courses. I think one
Okay.
is
So
available in from my institute, IIT Madras. There is one course for EMI EMC. But before doing that, I will recommend to do this
okay.
because
So for
it
that,
goes through the
yeah.
foundation.
Sure. Sure. Okay. Yeah. Thank you.
Yeah. Thank you.
Yeah. I'll be dropping now.
Yeah. Thanks. That's all because
We'll see you
the
on next
lecture
session.
is
Thank you.
over
Yeah.
already. It got over at around 7:40. I'm just waiting for the students to leave the group. Okay, thanks everyone. Thank you for for joining. Those who have joined late, the session is over, but the recording will be available on the this NPTEL course page.
Hello.
Yeah. Hello.
Hi, Rahul. Actually, I'm
Hi.
Sarvesh.
Yeah. Hi, Sarvesh.
Sorry, actually, I missed the sessions,
No
so I don't.
problem. Recordings will be available.
Yeah. So I think this is which week is this? This is the second
This
week or third week?
no. The current week which is going on in the course and the NPTEL page is second, but I am solving week one questions.
Okay, okay. So means we have the lectures, right? Actually I need to go through that
Ah,
site once. I'm
okay.
trying to.
Just first go through the lectures and then attend these sessions. These sessions are basically just problem solving sessions. So I won't be teaching much here, anything. I just will be repeating what professor has repeated. But the unique
Mhm.
thing here only is the questions that I will be solving. But to understand them, you should watch the lecture first.
Okay. How
And
many
if
lectures
time
are there, Rahul?
limits, you can go through the textbook also.
Sure. Yeah. This textbook, right? It is available in Amazon, something like that, or it is.
Yeah, yeah. It's good to have a hard copy. If you want, it's available in the Amazon. One paperback version is there,
Oh, okay, okay.
or
How much is
e-copy is
this?
also there. I got it for around 2 years ago, around 600. Now I don't know,
Okay.
but e-copy is available. You can download it for free also.
Sure, sure. And one more, how many lectures are there, Rahul?
So each week around 5 lectures will be there, and each lecture will be around 35 to 38 minutes long, not more than
Okay.
40 minutes, and there are 12 weeks. So around 60, 62 lectures will be there, not more
So
than that.
assignments will be there every day or per week?
Per week you have to finish them before the deadline because they carry some marks which will be well weighted at the end. So 40% for the end semester exam means the end exam, and 60% for the assignments. So there will be total 10 assignments or 12 assignments. Yes.
Oh, okay.
So each
So I
assignment
think
carries
already
some
first
marks.
assignment is already done,
No, no, no.
right?
Still the deadline is there. Still it is not over yet.
Oh, okay,
So
okay.
week zero assignment does not count for the marks. Week one assignment carries the marks. So still some deadline is there. I think because this is the first week, there is an extended deadline for week one.
This is the first week assignment, right? This is
Yeah,
second week, right? First week.
first
The
week
first
and
five
second week
lecture.
also is already available on the website. But first week assignment still deadline is there, so you can submit it.
Okay, I need to submit by through mail only, right?
No, 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 no. This online some questions will be visible to you and options will be there. You just have to select it and submit it. Everything is online through the NPTEL portal. I hope you
Okay.
have the link for the portal, right? NPTEL portal, where the
Yeah,
course
I'll
page
check
is.
that. Actually. Yeah, I'll check
Yeah,
that because this first day I joined today.
yeah. So I
I
am
will check.
basically a TA who takes some problem solving session where I help to solve your doubts.
Okay. So first five lectures I need to go through and I need to submit the assignment. That's the first
Ha
thing
ha.
now.
Yes, because first assignment is pretty easy. You can easily do it within half an hour. It won't take much time.
Okay, okay, sure, sure. I'll
Yeah. So
do that.
this is the course page if you want to go through. So everything is there in the course page. I hope you can see my.
Yes, I can see your screen. Yes.
Okay. So this is the
Oh,
week one, and still some time is there. I hope deadline
okay.
is there. Ha. Fourth is the deadline. Fourth Feb is the deadline.
Okay, still five
But
days. Okay,
but
still.
from now on, from week two, the deadline will be very short because this is the first week that there is an extended deadline. But the questions are pretty simple. It's pretty similar to what I have solved today.
Okay, okay. I'll do that.
Yeah. Okay.
And how the exam pattern is 25th something I saw in the mail.
Yeah.
Exam will be there, right? There is
Exam will be
online only, right?
it will be offline. You will be like it will be online, but not at your home. It will be at some university or some college, some nodal institute which NPTEL would have selected. So you have to select
Oh,
the city which is nearest to you, and they will allot one center.
okay. I need to go there and I need to. It the
Yeah.
exam also will be in this option.
Exam will be on a computer, but you have to be physically go to one center and give the exam. And the calculators won't be allowed, but on-screen calculator will be there.
Okay, I think the Excel and other things I can use, right? Excel sheets.
I don't even need, you don't even need Excel sheets there. It will be uh, calculators is needed. For that, online calculator will be there.
Okay, okay,
The
okay.
pattern will be pretty similar to what GATE exam looks like, GATE exam portal.
Oh, objective. All are objectives.
All are objective like this.
Okay, okay,
The questions will be pretty similar to the assignment problems that I can assure you. And
okay.
it is good to go through the textbook also once you go through the lectures. It's not necessary because professor covers everything, But just for if you want to learn more, it is good if you want to go through the textbook.
Sure.
Otherwise,
And
lecture in itself are sufficient.
okay, okay. And the same thing, previous person, just when I joined, one was he's asking. I am also
Ah,
working in industry. You
yeah, yeah.
said there is another course you recommend after this course, right?
Those are advanced level courses for working professionals, and I think you have to pay pretty more comparatively what you have to pay for this NPTEL course. But
How
that
much is it?
provides you a certificate, which is this also provides you a certificate. But it's always go through this first because this creates the base for that.
Oh, okay. I think this one examination fee, how much? I would,
I
sorry.
don't think so. It will be much around 1500 or 1200. I'm not sure about it, but it is
Yeah.
in that line only.
What about this course fee then? One examination
Course
fee in
is
that
free. If you
one?
don't want to give the exam, also you can attend the course. Course is free. All
Course
NPTEL
is.
courses are free.
Oh, okay,
But if you
okay,
want a
okay.
certificate, you have to go give the exam and register for that. That will cost around 1500 rupees. And then you have to clear
Oh,
the exam, then only you will get the certificate.
okay, okay, okay. I'll do
So
that.
there is no
Uh,
fees for attending the course. Anybody can attend online.
okay. So even still other courses as well there, in addition to the EMI?
Yeah, if you have time, you can go through the basic electromagnetic course.
Okay, okay,
So
okay,
it will be good if you have time. Otherwise, it's not very necessary, but good to have the background, which is also taken by the Professor Amitba Bhattacharya. So Professor has one more course already there in NPTEL, which is a prerequisite for this course.
okay. Electromagnetic.
This is because this is the only required knowledge, existing knowledge, electromagnetic theory for the course.
Okay,
There
okay,
are a lot of number of courses available on electromagnetic theory on NPTEL.
okay. Yeah.
Yeah.
Thank you for this platform. I think
Thank you.
this
Thank you.
definitely we will try to best utilize of this one.
Yeah.
And thank you, Rahul.
You can join every week for the live problem solving session. Every week we'll be meeting from 6 to 8 on every Tuesday of the week.
Okay, yeah. So every week you will be coming, right?
I will be
Every.
joining. So two sessions are happening. One on Saturday, which is taken by some other PA, and the Tuesday one I will be taking.
Oh, okay, okay. There are two sessions. Okay.
Yeah,
Yes,
both
Rahul.
are
Yeah.
going to be almost same. Means like we both are going to solve the problems.
Oh, okay. Yeah. Yeah. God,
Okay.
thank you for your
Thank you for joining.
information. Yeah.
Thank you.
Thank you, Rahul. Have a good time.
Thank you. Same to you.
Yeah. Bye.
Bye.